for Math 1314 and Math 1324, presented by Yvette Chuca, Ruben Carizales, and Albert Isasi. Our session will be starting soon. Again, this session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's events will be able to come and watch it. Let me start the recording. Alrighty. So now at this time, please mute your mics for best sound experience. Otherwise, the feedback could interfere with information we will be sharing today. Without further ado, here are our presenters.
Hello, everyone, and good afternoon. Thank you so much for joining us again for our TVE Happy Math Hour. We're on our second week, so hopefully you guys are all enjoying your classes, getting used to your instructors. So again, thank you for joining us. So for today's session, we'll be covering evaluating combination of functions and composite functions. So please feel free to raise your hand, ask questions on the chat on anything that we present here. Without further ado, let's go ahead and get started. So the first example that I want to work is evaluating functions. So the first example is, given this function, the square root of 3x minus 2, evaluate for the following x values or input values. So let's start with A. So when they say that x is equal to 2, what that means, again, everywhere I see x, I'm going to plug in this value 2. So I have the function, the square root of 3x minus 2. So I'll replace the x with a 2. So I have the square root of 3 times 2 minus 2. Let's go ahead and simplify. 3 times 2 is 6. And 6 minus 2 is equal to 4. So the square root of 4 is 2. So our first evaluation, when x is equal to 2, our function value or our y value is equal to 2. Okay. Let's go ahead and do B. It says to evaluate B when x is equal to a. So again, everywhere I see x, I am going to plug in this variable a. So we have the square root of 3a minus 2. Just to simplify, just 3a would be just 3a. So this would be our answer. Since we can't simplify any further, the answer that we would put on our web assignment or on our homework would just be exactly like this. The square root of 3a minus 2. Okay. And then the last one, C, evaluate the given function for 6 plus h. So again, everywhere I see x, I'm going to plug in 6 plus h. So we have the square root of 3 times 6 plus h. And since I have several terms, we always use parentheses. And if you notice, we like to get in a habit every time that we're inputting a value for x, we want to encapsulate it to make sure that we do the proper operation. So in order to simplify this, I need to distribute the 3 into the 6 and into the h. So this is going to give me 18 plus 3h minus 2. I can combine my two like terms. I have two constants. I have the 18 and the minus 2. That's going to give me the square root of 16 plus 3h. Okay, and I can't simplify any further, so this will be my answer. So when my input is 6 plus h, my output or my y value is going to be the square root of 16 plus 3h. Any questions so far on just evaluating functions? All right, very good. So let's move forward. So we are going to continue evaluating functions, but now we have the scary looking thing, right? But this is what's called a piecewise function. And it's called that because it's a function that's made out of two pieces or two individual functions. So if you see here, we have this function that has a minus 2x minus 2, and then it's also composed or made out of this other function that has x squared plus 2x minus 1. Now the key to evaluating these functions is that we're only going to get one answer. Even though that we have two functions, we're only going to get one answer. And the reason for that is that we need to verify the input that they're giving us, the x value. So this x value has to match the restriction on the domain that they're asking for us here on the right. So what this is saying is that for this function minus 2x minus 2, I only want to use the x values that are greater than -1. And for this function, x squared plus 2x minus 1, I only want to use the x values or the input values that are greater than or equal to -1. So let's go ahead and do A. They're telling me to evaluate the function at -4. So that means my x value or my input value that I want to use is -4. So I ask myself, is -4 less than -1? And that would be correct, yes, because -4 is not greater than or equal to -1. So this -4 only applies to the first line here, to the first function, to the -2x minus 2. So let's go ahead and evaluate that. We're going to evaluate f of -4 to this function, -2x minus 2. So again, just like the previous example, everywhere I see x, I'm going to plug in the -4. So let's simplify. A -2 times a -4. A negative times a negative is a positive. 2 times 4 is 8. This gives me 8 minus 2. So 8 minus 2 is 6. So again, when my input was -4, evaluating this piecewise function, my output or my y value is going to be 6. Let's go ahead and do B. -1. I'm going to do the same thing. Is -1 less than -1? No, they're equal. So it would apply to this second line or to the second equation. -1 is greater than or equal to -1. So -1 only applies to this function here, the x squared plus 2x minus 1. So let's go ahead and evaluate for this function. Again, everywhere I see x, I am going to plug in this -1. So -1 squared, a -1 times a -1 is a +1. 2 times the -1 is a -2. And we have the -1. Let's continue simplifying. 1 minus 2 is a -1, and a -1 plus a -1 is a -2. So when my input is -1 for this piecewise function, my output or my y value is going to be -2. Let's go ahead and do this last example, C. Evaluate the function at 1. So again, I have to see, is 1 less than -1? The answer would be no. Is 1 greater than or equal to -1? The answer is yes. So this input of 1 only applies to this second line, to the x squared plus 2x minus 1. So let's go ahead and evaluate. F of x is equal to x squared plus 2x minus 1. Again, everywhere I see x, I'm going to plug in this value 1. So we have 1 squared plus 2 times 1 minus 1. So 1 squared is 1. 2 times 1 is 2 minus 1. So 1 plus 2 is 3, and 3 minus 1 is 2. So when my input for this piecewise function was 1, my output or my y value is 2. Questions on this piecewise function evaluation? Great. Again, if any questions, please put them on the chat. If you need me to slow down, please let me know, okay? All right, so let's review domain. As you saw, the restriction of the x values, thank you, Aaron. So the restriction of the x values that we put on a function are very important. And that's what domain represents. Domain represents all the x values that I can put to an individual function. So if I were to look at this graph, okay, hopefully by now we recognize that this graph is a representation of a line, okay, and lines go forever because of these arrows that we put here. So if I were to evaluate all the x values that are reproduced by this graph, I can say that this graph goes forever to the left and goes forever to the right. So then the domain for this equation is going to be all these values. So the questions that you ask yourself when you're trying to determine the domain is you ask this: does the equation have a fraction that has a variable as a denominator? If the answer is yes, then we'll have a restriction on the domain. Now, why is this? Well, you all know that we cannot divide by 0. If we try to divide by 0, we have a fraction and the denominator is 0, our calculator is going to tell us error, is undefined. We cannot have it. So we cannot use 0 when we have fractions. So we have to be careful when we have equations that have fractions. The second question that you ask yourself, does the equation have any square roots? or even roots that have a variable in the radicand. And the reason for this is because we know that we can't evaluate negative square roots, because if we try to put a negative number and evaluate it as a square root, again, our calculator is going to say error, or we know that is undefined. So we would have a restriction on our domain. And the third question that you want to ask yourself, does the equation have logarithms? Okay, now maybe some of you guys haven't heard of logarithms or you don't remember, but we will, in the future for pre-cal 1, we'll deal with logarithms by itself in more detail. Okay, but if yes, again, logarithms are very similar to the roots. We cannot have negative input values for our logs, because then again, they would be undefined or we would get errors on our calculator. Now, since the example that I gave you, again, had none of these, and also just by looking at the graph, because I have arrows pointing to the left or to the right, this is telling me that this graph is all x values to the left and to the right. And we are going to write the domain for this example using interval notation. And the interval notation is given by parentheses negative infinity to positive infinity. And the reason why we use also parentheses is because the infinity is not a specific number. Whenever we are including a number, we're going to use brackets. But we'll see some examples of this coming on. Okay, so let's go ahead and practice. Okay, find the domain of each of the equations below. Let's start with A. Y is equal to x plus 5. Um, Again, hopefully by now we've dealt with equations in class, and if you see that this equation is in slope intercept form, right? So it's representing a line. So I know that lines, just like my first example, go forever to the left and to the right. So the domain for A would be from negative infinity to positive infinity, right? And again, you would ask yourself these questions, right? Does the equation have a fraction? No. Does the equation have a square root? No. Does the equation have a log? And logs, when you see them on a problem, they're going to say log, log, right? So it doesn't. So it doesn't meet any of these criterias. So again, the answer for this problem A is from negative infinity to positive infinity. It's all x values that this function will take. Okay. All right. Let's go ahead and just to verify, we would graph it, and we can see that this graph indeed goes forever to the left and goes forever to the right. Okay. So let's go ahead and look at B. Okay. Um, B, we can see that, again, if we answered all our questions, or we asked ourselves all the questions, this has no fractions, has no square roots, and it has nothing that says log in it. So since that's the case, again, this function, its domain, all the x values that I can put into this function are from negative infinity to positive infinity. Okay. So, and if we were to graph it again, this produces this parabola, okay? And again, we will be dealing more in detail with these types of functions and these types of graphs in the very near future. But for right now, just this graph represents a parabola, and you can see that it has arrows that point forever to the left and point forever to the right. So again, the domain is from negative infinity to positive infinity. I mean, yes, positive infinity. Now, let's go ahead and this should be C and D, right? So it's not A and B, but let's look at this first one. Y is equal to 1 over x plus 4. So we see that we do have a an equation that has a fraction in it. So we know that x cannot be 0, because if it is, then we have an error, right? Or it's undefined. So since we cannot use 0 for x, okay, that's our restriction. We have to exclude this number from our domain. We cannot use 0. So the way we're going to write that in interval notation, again, this is the English representation of our domain. The domain is all real numbers except 0, but for our computer, they're going to ask us to write it in interval notation. And the way we're going to write it is like this, okay? So we have all the numbers to our left and zero, meaning our negative numbers. So again, the smallest negative number is the negative infinity. Again, we're going to use parentheses because there's no number for infinity. And then we go up to zero. But again, because we cannot use zero, because we'll get an error on our calculator or for the equation, this also has a parentheses that it's from negative infinity to zero and all the numbers in between, not including these two endpoints. Now, because we have another set, the positive, we use this symbol that looks like a big U, capital letter U. Okay, this is again interval notation. It stands for union or and. So it's from negative infinity to zero, and the other half, the positive side, from starting from zero all the way up to infinity. Okay, so this is the answer for this particular problem. Now let's look at B. Oh, we can also say that this problem also has a fraction, but it's not just x by itself. It has x minus 6. So if you don't see it, you would want to solve for a value that we would put into x that might give us 0. So if you don't see it right off the bat, set it equal to 0. Set the denominator, x minus 6 is equal to 0, and solve. And if we do that, if we add 6 on both sides, that means that x is equal to 6. So if I would put 6 into this equation, 6 minus 6 would give me a 0 in the denominator, hence it would give me undefined. So for this particular equation, I can use all real numbers except for the value 6. So then it would be the same as the previous example. The domain for this equation is all values from negative infinity to 6, again, not including 6, and from 6 to positive infinity. Okay. Questions on finding the domain of an equation or a function? All right, very good. So again, if we were to graph these two examples, if you see here on this first one, at 0, our graph does not touch or cross this value 0 because again, it is undefined, right? Thank you, Ed. And if we look at our second example over here, we have an imaginary line that the graph does not cross or touch at the value um, positive 6. Actually, this should be on the other side. So it has it on the negative 6, but it should be on the positive side 6. Okay. Now we will be dealing later when we deal with rational expressions or fraction equations. We'll be talking about these imaginary lines in the near future as well. Okay. All right. So let's continue practicing finding the domain uh, of equations. So let's look at this one. What is the domain of y is equal to square root of x? Oh, this one has a radicand, right? This has a square root. So what can we not evaluate for square roots is negative numbers, right? So when we write the domain for this one A, it has to be all numbers that are greater than or equal to 0. So our domain is written as an equation, x is greater than or equal to 0. And as interval notation, again, we write bracket because we can include 0. So that's why we changed the syntax. Now it's a bracket because we can include the 0. And it starts from 0 and all the way to positive infinity. Okay. How about this next one? Very similar, but now we're doing something to x. So again, if you don't see it, we can solve for x to see if it's ever greater than or equal to 0, right? So when we do this, we see that if x is greater than or equal to -5, we will get errors. So example, if I plug in um, um, -5, well, that will give me an answer, right? So I can include -5. But if I use um, -6, right? So -6 plus 5 will give me a -1. Cannot use that one. So the values that I can use are from -5 to positive infinity. I can use -4, -3, -2, -1. Okay. So again, in interval notation is bracket -5 all the way up to positive infinity. Okay. Questions? Okay. All right. So then if I were to graph these equations, again, you can see that the only values that exist for x on this particular one is starting from 0 and all the way to the right. This arrow shows that this line goes forever to the right, so to infinity. Okay. And if I look at the second example, I see that the values start at -5. I include that value, -5, 0, but it go forever to the right. Yes? All right, very good. So now let's evaluate functions graphically. Okay. So let's go ahead and start with this example. Okay. So we have a graph. Okay. And it looks like this big W. And let's just review a little bit here what we see on the graph. So do you see on this graph, when we read a graph to begin with, okay, think about reading a book or when you're reading a line. We always read things from left to right. So when you're reading graphs in mathematics, you're going to do the same thing. We like to read the graphs from left to right. Okay, so the first left point here, we see that it's an open circle. So what that means is that the graph starts here, but I'm not including that point. Okay, so the graph is again like a W, and then it ends here with a solid circle. So that what this means is that because the point is filled in, this point does exist. This point is valid. Okay, so let's go ahead and evaluate. When they say that I want to evaluate this graph at f equals -1, what they're saying is this is the x value. What is the y value according to the graph? So if we go to the x value of -1, where you have this blue pointer, okay, here's -1, and then we go down to see where it hits the graph. So we see that the graph hits at y equals -4. So that is our answer. So when x is equal to -1, our y value is going to be -4, right? So again, I keep getting ahead of myself. But before I do this, we also want to evaluate again to just be aware of what's valid and what's not valid. So if I wanted to find the domain of this function, that graph that they're giving me, again, I see that this graph starts from -2 to +2. And then again, how is it indicated that I'm not including the -2 on the left and I am including the 2 on the right? Again, with these symbols, right? The parentheses means that I start at -2, but I'm not including it. And the +2, I am including it, so it has the bracket. All right. Now, what about the range? We reviewed a little bit the domain. So if domain refers to all the x values, so the range, the opposite of that, refers to all the y values that the graph contains. Okay. So we can do the same thing. If we look here, the graph of this, the smallest y value that we have is at -4, and our largest y value is at +5. So if I were to write the range in interval notation of this, again, we always do it from left to right or from bottom up. Um, the range for this would be, this first one is negative. I am including that point, even though there's not a point, but the graph is a solid line. So it means that it does include this y value. And then my highest value is 5. Even though it's not valid on the left, the graph still, the highest point is that +5. So I do have the bracket 5 on the right. So the range is from -4, including -4, to +5, including the +5. Okay, so again, going back to evaluating my function, you all saw that when I plugged in the -1, we traced it, and it gave us the graph where it crosses, where it touches, and this is at -4. Now let's look at x equals 0. So I want to find out what value of y is when x is equal to 0. So that's here at the origin. So if I trace it to find out where the graph crosses it at this line, I see that it's at -3, right? So the answer is -3. What about f of 1? This is telling me again the x value of 1. So when I go to the x value of 1, again, it's to the right of 0. So I scroll down. Thank you, Ms. Chuka. I scroll down and I see that it's also a -4, right? And then the last example, evaluate the graph at 2. So I go wherever 2 is, so it's about there. If I trace it where it hits, I go up and it looks like it's +5. Yes? So the answer would be when x is equal to 2, my y value, according to my graph, is 5. Great. Any questions using graphs to find the function, find the domain and range of a graph? Very good. All right, let's go ahead and move forward. Let's look at this example. Again, let's start with find the domain and range of this graph. Again, when you're finding the domain and range, we want to look at the graph as if we were reading it from left to right. So let's start with the domain. I see that this graph has an arrow pointing to the left, forever to the left. So I know that the start of the domain is from -infinity because it goes forever to the left. Okay? Now, let's keep on reading. So it goes to the right, and then I'm including 1, okay, here. I'm not including 1 here, but then after 1, even though it's an open circle, it does pick up, right? The graph keeps on going to the right and forever to the right because I have an arrow. So then the domain for this graph would be still from -infinity to +infinity. Okay, so let's look at the range. Okay, what is the smallest y value? Now, on this one here, it's saying that I start at -2. That's the smallest y value, but because it's an open circle, I'm not including that. And so how do I indicate that in interval notation? I'm going to use a parentheses, but I start at -2. And then what is my highest y value? Well, both sides of these lines point forever up. So my highest value is that positive infinity. So again, the range for this in interval notation is starting in -2, but I have to use parentheses because I'm not including that point, and it goes forever up to positive infinity. So now that I found the domain and range, let's go ahead and evaluate the given points, right? So let's start with f of 2. What is the value of y when x is equal to 2? So then I go again to the graph at 2. Okay, it looks like I'm intersecting there the line. So I would say that my y value is 0. Okay, because I'm right there. The line is crossing the the 2 at that particular spot at the x-axis. Yes? How about 1? What is the value of y when x is equal to 1? Again, this is the same thing. At 1, it's indicating that I'm there. I'm at the x-axis. So then y is equal also to 0. And then what's the y value when x is equal to 3? On this one, I have to trace the graph. At 3, I go up and I look at it and it looks like about 2 more or less. I think it's 2, right? So I would say, thank you, Aaron. Yes, I agree. The value is 2. Okay? And then let's go ahead and do the last one. What is the y value when x is equal to -1? So I go to my graph and I see where it hits my graph. So I'm guessing it's about halfway between, oh no, this looks like 2 as well, right? So I'm going to say 2 as well for this one. So yes, so again, at when x is equal to -1, my y value is 2. Any questions so far? Great. All right. Let's go into combination of functions. Okay. So um, what the way I like to think of combinations of functions is you're doing basic operations with functions. And what are the basic operations that we do in mathematics? Well, we add, subtract, multiply, and divide. And this is what we're going to be doing with the combination of functions. We're going to be adding, subtracting, multiplying, and dividing fractions. Oh, it's easier than it sounds, okay? So let's say that they gave us these two functions. Function f of x, which is 3x minus 7, and function g of x, which is 4 minus x. So if I want to do this first one, let's practice adding two functions. And the syntax for that is f plus g of x. Okay, this is telling me that I want to add function f with function g. So to do this, you just write them out. You first write function f, I would rewrite it, f of x plus function g of x. Okay, and then all you have to do is substitute function f with 3x minus 7, function g of x with 4 minus x, and simplify. So let's go ahead and do that. We replace function f of x with 3x minus 7. We replace g of x with 4 minus x. And let's simplify. Let's combine like terms. So let's combine our x's. I have a 3x here and a minus x. So 3x minus x, that's going to give me 2x. And then I have two constants, right? I have two numbers that don't have variables. So I have the minus 7 and the plus 4. So minus 7 plus 4 is a minus 3. So the final answer is 2x minus 3. And that is my answer. When I add function f with function g, I'm going to get 2x minus 3. Okay? Let's try the subtraction of two functions. I would do the very same thing. This is the syntax that is given that represents the subtraction of two functions, but I would rewrite it. This is all it's telling me to do is subtract function f with function g. So all I need to do now is go ahead and substitute function f of x with 3x minus 7, function g of x with 4 minus x, and simplify. So let's go ahead and do that. So since we have a negative, you wanna be careful because since our function g has two terms, we gotta make sure that we distribute the negative before we start simplifying. Okay, so let's go ahead and do that. Let's distribute the negative. So a negative times a positive, that's gonna give me a negative 4. A negative times a negative is gonna be positive, so it's gonna give me an x. So I'm gonna have 3x minus 7 minus 4 plus x. Now I can combine my like terms. So I have two like terms that have a variable, the 3x and the x. So 3x plus x is 4x. And I have two constants or two numbers that don't have variables. I have minus 7 and minus 4. So there's going to be minus 11. Yes? So our answer is 4x minus 11. When I subtract function f with function g, the answer is 4x minus 11. Questions so far? I hope this is easy stuff, right? All right, let's go ahead and do the product of two functions or the multiplication of two functions. And again, the syntax that you're going to see is FG. You all know that when two things are right next to each other, we don't have to put a symbol of multiplication. We know that what they mean when two things are together is a product or multiplication. So again, I would rewrite it. What are they asking me to do? What they want me to do is multiply function f with function g. So I'm going to go ahead and substitute what f of x and what g of x is with 3x minus 7 times 4 minus x, excuse me. So on this particular one, to simplify, I have to do FOIL, right? This 3x has to be multiplied with both of the terms of the other, which is 3x has to be multiplied with the 4, 3x has to be multiplied with the minus x, and then the minus 7 also has to be multiplied with the 4, and also has to be multiplied with the minus x. So if we do this, we have 3x times 4 will give me the 12x. 3x times a minus x is going to give me a minus 3x squared. Now the minus 7. Minus 7 times 4 is going to give me the negative 28. A negative times a negative x is going to give me a positive 7x. So let's go ahead and combine like terms. We don't have any terms that have an x squared, so this one's by itself, but we do have two terms that only have an x. I have a 12x and a 7x. So 12x plus 7x is 19x. And we didn't have any constants. We only had one constant or just one number that had no variables at minus 28. Now, when you put things on the computer, the order really doesn't matter, but in mathematics, we like to have some order, right? It's all about order. So normally when we simplify this and combine our like terms, we like to write them what's called standard form, and standard form is in descending order. The highest exponent variable goes first, and then down the line. So I would write this as minus 3x squared plus 19x minus 28. Again, when you're inputting these on the computer, it's not picky on the order, but we want to practice always doing things in standard form. All right, let's go ahead and do the last example. Okay, so the syntax for a division of fractions is f divided by g. These are over each other. Again, what do they want us to evaluate? Well, all they want us to do is this: divide function f with function g. So let's go ahead and substitute what these represent. So we have 3x minus 7 over 4 minus x. Okay, can I simplify? Can I do anything to this fraction? Well, the answer is no. Okay, there's nothing that they share that I can cancel or eliminate or reduce. So then that is my answer. The answer of f divided by g is just 3x minus 7 over 4 minus x. Now, on your homework, when you're doing these types of problems, your homework will always ask you, because we had a fraction as an operation, they're going to ask us, what is a domain of f divided by g? So again, we practice that when we have a fraction, we got to be careful that our denominator is never equal to 0. So if you don't see it, again, set it equal to 0. Is 4 minus x equal to 0? Is there a value for x that will give me 0? And the answer is yes, right? If I plug in 4 for x, 4 minus 4 will give me 0. So again, the domain for this problem is all real numbers except 4, but the computer is going to want it, WebAssign will want the answer in interval notation. So again, an interval notation is from negative infinity to 4 and from 4 to infinity. I forgot the parentheses, sorry. Okay. Questions? Awesome, guys. Let's move forward. All right. Let's go ahead and do more of this practice of the combination of functions. So let's add function f with g. Again, we rewrite and we'll replace. Yes? So here, function f of x is just x squared. Function g of x is 2x minus 5. We simplify, but there's nothing to simplify because there's nothing to add. There's no like term. So that will be our answer. Our answer is just x squared plus 2x minus 5. All right, let's go ahead and do the subtraction. So subtract, we're going to rewrite f of x minus g of x because that's what they want. I'll do the replace. F of x is x squared. G of x is 2x minus 5. Again, because I have a subtraction or a negative number here is like -1, I use a parentheses, right? I have to distribute that sign. So when I distribute, I have x squared minus 2x plus 5. Again, and that's it. There's nothing to combine. There are no like terms. All right. What about the product of f with g? So again, we rewrite f of x times g of x. We replace f of x is x squared. G of x is 2x minus 5. So we'll distribute the x squared to these two terms. X squared times 2x. X squared times a minus 5. So when I do that, x squared times 2x is 2x cubed. X squared times a minus 5 is a minus 5x squared. Again, I only have two terms. I cannot combine these two terms because they're not like terms. This is a cube term. This is a square term. So that is my answer. 2x cubed plus 5x squared. Okay. Now, the last one is the division, right? The division of f of g. So we replace f of x divided by g of x. So we'll go ahead and substitute x squared over 2x. And we try to simplify. Can we simplify? Is there stuff that we can factor that can cancel out? No. So then again, our answer would stay this way. Our answer is just x squared over 2x minus 5. But then again, our homework is going to ask us to find the domain of this function of f divided by g. Again, we know that our denominator cannot be equal to 0, so if we don't see it, let's solve for it. Let's set it equal to 0. 2x minus 5 is equal to 0. So to solve for x, I'm going to add 5 on both sides, divide by 2, and I see that if x is equal to 5 halves, I will get a 0. So then again, the domain is all real numbers except this value, 5 halves. So in interval notation is from negative infinity to 5 halves, union from 5/2 to infinity. So I apologize, these are backwards, okay? It's first the 5/2 and then last is the negative infinity, okay? Any questions? All right. How about this one? Let's go ahead and practice with these two functions, okay? F of x is equal to x squared plus 3. G of x is equal to the square root of 2 minus x. So let's go ahead and do the addition. Again, we represent what they mean. We replace, and then we simplify. Okay, so here, since we cannot simplify, the answer will stay like this. Okay, so again, this order doesn't matter. If you put it in the computer the way it is on the second line, the computer will accept it. Okay, but we like to see things again in standard order. We rearrange things. We always like to have our constant at the end, but don't panic too much on the order. Okay, the computer will take the order if your numbers are correct. Okay. All right. Let's go ahead and do f minus g of x. So again, f minus g of x is just subtracting function f with function g. We go ahead and replace. Again, because we have a negative or a subtraction, we want to encapsulate the square root of 2 minus x. Let's go ahead and distribute that negative. So basically, it's just a negative to the square root of 2 minus x, leaving us with x squared plus 3 minus 2x. Can we simplify? No. Again, so our answer will just stay like that. Again, you can put it in like that, like the calculator, or you can put it, again, the constant at the end. It really does not matter as long as your values are correct. All right, let's go ahead and do the product. Let's go ahead and rewrite by saying that what they want is f of x times g of x. We substitute what those are. So again, we need to distribute or do FOIL, right? The x squared has to be multiplied with the square root of 2 minus x, and then the 3 has to be multiplied with the square root of 2 minus x. So when I do that, okay, actually, I can do that and separate it, but if you input it like this on the computer, it's gonna accept it, okay? You could write it as x squared times the square root of 2 minus x plus 3 times the square root of 2 minus x, and I would have taken it, but if you leave it like this, the computer will accept that answer, okay? It's already simplified. Then the last one, f divided by g. So we replace function f of x is x squared plus 3. Function g is the square root of 2 minus x. Can I simplify? No, there's nothing to factor, there's nothing to cancel. So that would be my answer. So now it's going to ask me what is the domain of this function. So we never want a 0 on the denominator. So if we don't see it, there's several ways to solving for x on this one. So the first one is by doing the elimination, right? So here we set the square root of 2 minus x is equal to 0. Okay, so we take the square root, or we squared both sides, excuse me. So this square will eliminate the square root, leaving me with just a 2 minus x, and then 0 squared, of course, that is 0. Solving for x, we subtract 2 on both sides, and then we have to multiply by a negative on both sides, which will give me x is equal to 2. Okay, so we know that I can put any value here for 2, but we have a square root. Remember, we have to evaluate that we cannot have negative numbers inside our square root. So we say, okay, now I know when it's equal to 0, but now let me find out all the values that I can take, right? So this 2 minus x has to be greater than or equal to 0. So let's find for those values. So x has to be less than or equal to 2, right? So here, what we can do is, um, sorry, x has to be greater than 2. So my symbol here is backwards. So x has to be anything greater than 2. So the interval notation would be from 2 to in no, hold on guys. Let me see here. If I have 2, 2 is 0. If I have 3, so no, anything smaller than, anything bigger than 2 cannot be used. So it's from negative infinity to 2. So my notation is correct. Sorry. Okay. Does everybody see that, right? So if I put x equals to 2, 2 minus 2 is 0. But if I plug 3, right, something bigger than 2, 2 minus 3 will give me a negative number. So it has to be everything smaller than 2. So it's the wording that got me off here. So it's everything smaller than 2. So the interval notation is from negative infinity to 2. Okay? All right, questions? All right. Um, Now let's look at what's called composite functions, okay? So this symbol here, this open circle, that it's read like this: F composed of G, okay? We also can do G composed of F, and we can also do G composed of G, okay? Um, so when we're doing the composites, what this really means is that instead of evaluating the function at a given number, we're evaluating the function and putting in another function. That's what this means. The first function that you see is your principal function, and the second function that you see is the one that I'm putting into the first function. So if I have these two functions, f of x is equal to x plus 4, and g of x is equal to x minus 3, if I want to evaluate f composed of g, what this is saying is that for function f, instead of putting in the value, what I'm going to put in is this other function, g of x. Okay, so I like to rewrite the composite in this format: f of g of x, because this is telling me that I'm going to put into function f g of x. So let's go ahead and replace this. Function f is or function g is x minus 3, and everywhere I see x for the function x plus 4, I'm going to plug in this value, x minus 3. So let's go ahead and evaluate. So everywhere I see x, I would plug in x minus 3. So I would have x minus 3 plus 4. Let's simplify. Minus 3 plus 4 would be a 1. So the composite of f composed of g is x plus 1. Okay? All right, let's practice some more. Let's do g of x. Let's do the opposite. Okay? So since g is first, that is talking that's my main function. That to the function g, instead of putting in a value, I'm going to put in a function. In this case, it's function f of x. So f of x is x plus 4. So everywhere I see x in function g, I'm going to plug in x plus 4. So when I do that, I have x plus 4 minus 3. Again, I'm going to simplify. Plus 4 minus 3 is going to give me 1. So g composed of f is x plus 1. Now, I do got to say this. On this particular example, we got the same value, but this isn't always the case. It just happened to be in this particular problem, but it's never this. It's almost never the same. Okay, f composed of g and g composed of f will not always give you the same answer. So don't think that it's supposed to. Okay, all right, and let's do the last one. And we get a lot of questions on this one from our students. They're not sure how to evaluate this, but it's straightforward. What this is saying is that I want to evaluate g composed of g of itself. So what that means is I have function g, and to function g, I'm going to re-put the same function g, right? So replace g of x, which is x minus 3, and to this equation, x minus 3, everywhere I see x, I'm going to plug in x minus 3, right? So then we have x minus 3 minus 3. We simplify by combining our like terms. We have a minus 3 with a minus 3. This is going to give me a minus 6. So f composed of g is equal to x minus 6. Okay? Any questions so far? All right. All right. So let's go ahead and practice a little bit more. I'll go a little bit quicker because I do want to get through all the information. So I'm going to do first f composed of g. I'll rewrite it. Okay. So everywhere I see x for the function x squared, I'm going to plug in this value, x minus 2. So we have x minus 2 squared. you would do FOIL, because what this means, x minus 2 squared is x minus 2 times x minus 2. When I do that, I get x squared minus 2x plus 4. We combine the like terms, and we're going to get x squared minus 4x plus 4. Okay, let's go ahead and do g of f. Again, I have function g, and everywhere I see x, I'm going to plug in function f of x. So I have x minus 2 for g of x, and I'm going to plug it into this function, x minus 2. So we have x squared minus 2. I simplify, cannot combine like terms, so my answer is just that. It's going to be x squared minus 2. Okay, and then the last one, g composed of g. So it's just g of x. So g of x is x minus 2. Everywhere I see x to x minus 2, I'm going to plug in x minus 2. Combine on like terms is going to give me x minus 4. Okay? Questions? Awesome. All right. Let's quickly do these. If I have function f of x is the square root of x plus 4, and function g of x, which is x squared, let's do this composite, f composed of g. So because f is first, I'm going to plug in everywhere I see x, the x squared for function f, right? So we have the square root of x squared plus 4. Now, don't be tempted to cancel these out. We have the square with the square root, but because this is together, the x squared plus 4, we cannot separate it. So this is our answer, right? The composite of f composed of g is just this, the square root of x squared plus 4, okay? How about g composed of f, okay? Everywhere I see x for x squared, I'm going to plug in the square root of x plus 4, okay? So I'm going to plug in the square root of x plus 4. So we have the square root of x plus 4 squared. Okay, on this one, I can simplify. The square will eliminate the square root, leaving me with just x plus 4. Okay. Now, if we want to find a domain for our first example, okay, we have to find the domain for each of our functions. So let's look first at our function f of x. The function for f of x, again, we have a square root. So we know that we cannot put negative numbers into our square root. So we see that all the numbers that we can put on this that will not give us negative numbers are from -4, because -4 plus 4 will give me 0. But I can put anything greater than that of -4. So -3, -2, -1, all the way up to positive infinity. So that's the domain for the function f. And then the domain for function g is all real numbers, right? There's no restriction. So it's from -infinity to positive infinity. Okay, so when you're writing the domain for f of g, you need to consider both of these, right? So since no matter what you put for the x on the radicand, okay, we can have the domain for g for -infinity to positive infinity. Okay, all right. Now, let me go ahead and go through, since I have 7 more minutes. I think we've done several of these. Let me see what's here at the end. Um, see one that's different.
Maybe go to the increasing, decreasing towards the end,
Yes, right?
because I know people have questions about that one. So
Okay. Thank you, Vet. Okay. So let's look at this problem here. It says determine the open interval function is increasing, decreasing, or constant. Okay, so as I mentioned to you, when we're reading graphs, we always read graphs from left to right. So if you see that a line is going up, 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 that means that it's increasing. If it's going to the positive direction, that means if it's increasing. If we're reading a graph and we see a line that is sloping down, because we covered slope already, right? If it's going down, we know that is decreasing, right? And what is constant? Well, constant means like if you flatline, if it's not moving at all, it's just a solid horizontal line. Well, that means that it's constant. So first, and when we look at this graph of x squared minus 12x, we see that the graph is a parabola, and we don't see any straight lines or any horizontal lines. So the answer for this problem has no constants. But again, if I'm reading this graph from left to right, I see that from the left, I'm going down, right? It's like scribbled all this in red. It's going down, but where does it stop going down? At this point here, right? At 6, -36, okay? So from negative infinity to, again, when we're writing the domain, the x value is the 6, right? Which is in green here. So from negative infinity to 6, the graph is going down, down, down. So on this part, it's decreasing, okay? Now, what about the increasing? Once I pass 6, I see that the graph starts moving up, like here in blue, and it goes up, 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 and because I have an arrow here, that means it goes forever up. So then I have two situations, right? I have a situation where the graph is decreasing, and I have a situation where it's increasing. So when I'm writing this in interval notation, again, I'm going from left to right, from negative infinity to 6. That's where it's decreasing, and from 6 to positive infinity, that's where it's increasing. And the way we indicate that we don't have anything that is a line that is horizontal, we write this on our computer, DNE, which stands for does not exist. There's no place in the graph that is just constant, that is just moving forward. Okay? Any questions? Let's see. I have another example of this. All right, so let's look at this one right here. So if we were to look at this graph, again, we want to read this graph from left to right. So again, we don't have the arrows, but this is indicating that this graph is going forever to the left. Okay, but thank you, Yvette. So when we reading this, okay, we know that it's going forever to the left, and then it stops here, right? It stops here at this value -5, and then the graph continues here at +5. It's going up, right? So just the same situation as we had before, okay? In this left side here, we're reading from left to right. It's decreasing, decreasing until we stop here at -5. And then we jump from 5 to on, it's increasing. So the way we label this in interval notation, it's decreasing from negative infinity to -5, and it's increasing from +5 to infinity. And then the constant, we don't have any constant, does not exist. Yes? All right, I think I have like um, um, 2 minutes, right? But I think it's corrected now, right? So it's increasing from 5 to infinity and decreasing from negative infinity to -5. And again, we do not have any slots where it's constant. Any questions? All right. Thank you again for joining us today. Please, if you have any further questions, we have some awesome tutors that are willing to stay with you and help you out with any additional questions you may have. Please don't forget to register attending our session. Again, instructors will give you credit for tutoring for those who need tutoring credits. Please don't forget to click on the link. Also, we encourage you to fill out our survey. And again, thank you for joining us today. Any last words, Ms. Chuka?
No, just that next week we're gonna be covering, I believe, factoring, and hopefully you guys can join us because factoring is gonna play an important role, especially starting in chapter 2, and so it's kind of a preparation for you to get ready for chapter 2.
Thank you, everyone, for coming. Thank you, Mr. Carrizales, for presenting today. Thank you for Ms. Chuka and Mr. Azasi for being here and being awesome. I would like to thank all the students for taking the time out of their Friday to come and attend our session. And as Ms. Chuka said, next week in this very room on February 4th At 1 p.m., we'll be doing Student Success Tips by the Center of Students with Disabilities. But at 3 p.m. for Happy Math Hour, we'll be reviewing different methods of factoring. Thank you all, and I hope you have a wonderful weekend.